Hello, this video is about graphing techniques. We're going to start off talking about dependent and independent variables. Independent variables are variables that you manipulate, you control. And dependent variables depend on what happens to that independent variable. So it will change when you change the independent variable. Usually when you make your data table, your independent variable is on the left. Make sure you label what it is and the unit in parentheses. And your dependent variable is on the right. Again, label what it is and the unit in parentheses. So here's some sample data that we have. What we did was we pushed a bowling ball, and as soon as we let it go, we started a timer, and at time equals 0, it was at a position of 0.5 meters. Then we pulled the bowling ball back, gave it another push, let it go, and at 2 seconds, it was at a position of 1.2 meters. We repeated that process. So we gave it another push, and after 4 seconds, the bowling ball had traveled 2.7 meters. And that's how we got the data that you see here. Now what we're going to do is actually graph that. So we talked about dependent, independent variable on a data table, but on a graph, where does it go? So if I peel this off and put it out of the way over here so I can see. The independent variable always goes on your x-axis, your horizontal side. And the dependent variable goes on the left-hand side or the vertical side. So again, you want to label what it is. So I've got time in seconds. And over on the y-axis, I have position in meters. So one of the very first things we need to do is determine scale. So on this sheet of graph paper, I know I've got 45 blocks on this long side, but I only go up to 12. So if I take the biggest number after graph, which is 12, and divide by the number of blocks, which is 45, I get an answer of 0.26 repeating. Well, that's not a good number to count by. So I want to round up to it's a nice number to count by. So the next number up, I would say, would be 0.5. So every block's worth 0.5. So we start off at 0 right here. That's 0.5, but I don't necessarily want to write that in because it's going to make the graph too cluttered. That would be 1. That'll be 1.5. That'll be 2. That's what I want to go ahead and write down, 2. That way it spreads it out and doesn't make that horizontal axis look so cluttered. So again, every block is worth 0.5. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And as long as you go at least halfway along that side, you're going to have a good graph. Now up the left-hand side, we've got to get to 6. And I know there's 30 blocks of this side. So I want to take 6 divided by 30, and we get 0.2. That came out to be an exact number, and 0.2 is a good number to count by, so that means every 5 blocks is 1. So that's 0.2, 0.4, 0.6, 0.8, 1, 0.2, 0.4, 0.6, 0.8, 2, 2, 0.4, 0.6, 0.8, 3, 2, 0.4, 0.6, 0.8, 4, 0.2, 0.4, 0.6, 0.8, 5, 0.2, 0.4, 0.6, 0.8, 6. Now, I did make a small mistake right here, but that just shows you that you also need to use a pencil when you're doing this, because that's actually 4 there. 4, 2, 4, 4, 4, 6, 4, 8, 5 would be there. And that would make 6 right there at the very end. Okay, so now we've got the scale figured out. We've got our axes labeled. And so now we need to go ahead and plot the position of each point. So at 0, we're at 0.5 meters. So that's 0.2, 0.4, 0.5 will be in between. You may have to estimate the points because they won't be nice and be exactly on a line. Now at 2 seconds, we're at 1.2, which actually is on a grid. At 4 seconds, we're at 2.7. So there's 2, 2.4, or 2.2, 2.4, 2.6, 2.7 would be there. At 6, we're at 3.6. So there's 3, 3.2, 3.4, 3.6, 8, 4.2, 8, we there, 10, 4.7, be there, 4, 4.2, 4.4, 4.6, 4.7. Okay. And at 12, we're at 6. Okay. Now, the next part would be for us to draw a line of best fit. Now, for your line of best fit doesn't have to hit all your points. It does not go from the very first point to the very last point. It actually doesn't have to hit any of your points. It just has to follow the trend, trying to split the difference between points above and below the line at best equal distance. So it wouldn't be straight across like this, but it would kind of follow this line right here. So let's draw the line of best fit. All right, to draw the line of best fit, again, we want to follow the trend, but we're not connecting the first dot to the last dot. We want to try to get an even balance between points above and below. So let's try this one here. Okay. We've got 3 above and 4 below. We probably could have dropped that line a little bit lower, but that's okay for right now. We're going to go for that. And we're going to determine the slope and what that slope means for this graph. So to determine the slope, we want to talk about the change in y over the change in x. All right, to determine the slope, we're going to do the change in y over the change in x, which really just means y2 minus y1 over x2 minus x1. Well, we need 2 data points for that. So what I prefer is to look for data points like this one, where your line actually crosses the horizontal and vertical lines in the graph, so we can tell exactly what that point is on both sides. And you want to pick them as far apart from each other as possible. So my other one I like is this one here. And so if we look at that, we've got this point here. That's 5, that's 5.2, 5.4. So that's 5.4. Y1 will be this point, which that's 1, 1.2, 1.4, 1.6. Over on this axis, that point is 10 and a half. And this point will be 2. We just calculate that. So if I do 5.4 minus 1.6, 3.8, 10.5 minus 2, 8.5. Now if we divide those, 3.8 divide by 8.5, we get a slope of 0.4, let's call it 5. But slope actually means something. So in this case, we have position divided by time. So we have a distance measurement divided by a time measurement. So our unit would be the distance measurement, meters, divided by the time measurement, seconds. So we've got this bowling ball was rolling at 0.45 meters per second according to our experiments. So we need to talk about that for a second. What does that mean? That means for every second, the bowling ball travels 0.45 meters. Now, what could be some errors in your graph? So if we had a wider pin, that would give us a larger mark here, so we wouldn't have as accurate data to choose points for our slope, and that could throw off our answer some. So you want as fine a tip pen or pencil as you can to make that line as thin as possible to alleviate some of those errors, so that you can use that slope and the y-intercept to actually determine an equation for how this object's moving. Thank you, and see you again in another video.